So in this lesson for 8.4, we're just going to talk about similar triangles. This one's really short because it's really the exact same concept as similar polygons. Basically, all that changes is there's one extra theorem for specifically similar triangles. It's this angle-angle similarity postulate, okay? So a lot of times they call it a similarity postulate, okay? Angle-angle, just like we used back in congruent triangle stuff. Okay, so if two angles are congruent to two angles of another triangle, then those triangles have to be similar. So if we have this triangle and this triangle, okay, I'm going to make them more different shapes for you. Maybe more different sizes. This one. Okay, so we have those two angles. If I tell you, or you're able to prove somehow that this angle is congruent to this angle, and let's say that this angle is congruent to this angle, then you can automatically tell me that these triangles are congruent to each other. So let's call this one ABC and this one XYZ. All right, that tells me that, for sure, without a doubt, triangle ABC is similar to triangle ZYX. Okay, remember they got to be in the same order, just like we did with with congruent triangles. All right, so dive right in. It's pretty straightforward here. So I'm gonna draw this diagram here. We're gonna assume that these two triangles are congruent. I'm sorry, not congruent, similar. Okay, we've got 36 degrees. 30. These are parallel. 106. 33. L, M, N, P, and O. Alright, so all this stuff we need to do with this problem. Okay, we know that these are similar. Why do we know that these two are similar? Well, let me show you. Okay, so here in black, we know that since this is 106 degrees, this one has to be as well because of vertical angles. Okay, and also, since this is 36 degrees, this is also 36 degrees. Why? Well, because these lines are parallel. Since we've got parallel lines cut by this transversal, those are alternate interior angles. So angle M is congruent to angle O because of alternate interior angles. Now once we have two angles congruent to each other in these triangles, that tells us that these two triangles are similar. So once the triangles are similar, we can write this statement of proportionality. Make sure you get it all in the right order. One way to make sure you get them in the right order, to make sure you have the corresponding sides with each other, is to look at the way this is written. Okay, that means that LM is going to be corresponding to PQ. So that tells me that LM over P, oh sorry, that's not supposed to be an O, that's supposed to be a Q, over PQ is going to be our first part of the scale factor, okay, our first ratio. Then we've got MN and QN over QN. And lastly, NL and NP. Okay? This is the statement of proportionality. These are all the proportional sides for these set of triangles. Okay? Now find angle M and angle P. Okay, so for angle M, we know it's already 36 because I told you, right, that it's congruent to angle Q. So since they're congruent to each other, it's also got to be 36. Now for angle P, well, we already know that this one's 106, and this one right here is 36. So you subtract those two both from 180 to get 38 degrees. Okay, simple subtraction there. Now lastly, to find MN and QM, I'm going to need to add another piece of information here. I'm going to tell you that QN here is 20. Okay, so if I tell you that QN there is 20, we're going to have to use our ratios to find the lengths of our sides. So we're going to find MN first. Okay, so if we find MN, right, that's going to be like our X. Okay, well we already have this proportion set up and we've got three numbers here. If you look at 33, 30, and 20 in X, well, we should be able to set up a good proportion with those. So let's try that now. Okay, well we know we're going to need MN in the proportion over QN, which is 20, and we want 30 and 33 in there. So since MN is on top, 33 is also going to have to be on top, and 30 on the bottom. Okay, then you can cross multiply and divide and find the answer. So we'll have 30 times MN equals 20 times 33, which is 660. Divide both sides by 30, and you will get MN equals 22. Just like that. Okay? Just simple proportion. I know it's difficult to see, but take some practice and you should be able to get it. Now, to get QM, you're just going to add up. QM is equal to MN plus QN, which is just going to be 22 plus 20. So QM is equal to 42. And you're done. Now, one other diagram I need to create here for the second example. We've got another big triangle. Okay, and then within this big triangle, we've got an altitude, and we have this little triangle in here. Okay, now this little triangle here, we're going to find the length of EH. So EH is going to be here. Let's put all these in here. B, that's D, that's F, A, C. Okay, so a couple lengths that I'm going to give you. AD here is 5. Okay, DB is 7.5. And CF is 6. Okay, those are the lengths that you got. So, a couple things that need to be done right away. First of all, one extra piece of information I'll give you is that these two are congruent, those two angles. All right, the reason that's important is because we need to know, we have to first prove that these triangles are similar before we're able to do anything with it. Well, these right angles, you might think that they are helpful here, but they actually aren't because they're not part of the triangles. Okay, we have this one set of angles that's congruent to each other. We need a second set to use angle-angle. Well, this is one trick that you're often going to see here. If we got this big triangle and this little triangle, they most often are going to be sharing one angle. So that means that this angle A, since it's in both of them, it's obviously congruent to itself. Okay, so that's our second angle, and we're able to use angle-angle to prove that those two are similar. Now we know this is similar, we can create our proportion. Okay, so we got this height here is x. So we're going to do 6 over x is equal to, okay, the 6 is corresponding to the 5 in the same triangle. And another trick here, right, the 7.5 is not the base of this big triangle, right? The base of this big triangle is 5 plus 7.5. So we're going to need to add them together to get 12.5. All right, now we can do our multiplication. Get 5x equals 75, and x equals 15. All done. Good luck, guys.